In this video, we're going to look at doing a plot, a custom plot of the intensity values of the image. That will work nicely with the feature we developed in the previous video, where we can rescale the intensity values. So it's nice to see what they are, so you know better how to scale. And this main function here, this update function, is becoming pretty huge. Eventually we will refactor it to some sub-functions and lay out in a better way. And we'll even start that process a little bit now. So let's make something that we call canvas, and it will take the UI struct so it can use that to create new things and know where to lay things out. So let's do that here. Canvas, it's a mutable reference to self, and this is, if I recall correctly, a mutable reference to UI. And we want to make a plot, specifically a histogram. So to do that, we want to have some like arbitrary drawing capabilities. And you can do that with the so-called painter in egui. And it takes a region, or region size rather. So let's start by making a kind of like a region of size 100. And it also takes a sense. And that could be, for example, click and drag. So it will be able to sense when we click and drag. And that will be useful later on, not here in the beginning when we are just trying to draw. So it returns a response and a painter. So let's get those. The painter might have to be mutable, but we'll look at that later. All right. So we have that, and now we can actually say add painter, and it has an extend method, and that can add shape. So I think we can even also say add maybe. Yes, that, so you can add a shape as well. And let's actually try that. So let's make a shape, for example, a filled circle. And where we're gonna put it, so this takes a position, if I'm not wrong, so it takes a position, and since we have a like an area of size 100, we could maybe put it in the middle, and we can add a color from RGB, and maybe we will make it red. Okay. And did I, yes, there we go. Expect 3 arguments. That's because we also need a radius. The radius could be 10. That's formatted. So this is actually not going to work because this will try to draw it at the screen coordinate 50, 50. That's not necessarily where the painting area is. So I think we have to get out the rectangle, if I'm not correct, it's here, and we have to add the left side at the top. And run that, and failed. So it's because these are functions. These are actually functions. Let's try again. This time it seems to be compiling. And now you can see we have this red circle drawn here. And you cannot see it, of course, but there's supposed to be kind of a drawing area here. You can actually try to draw the drawing area. So let's add another shape. For example, a rectangle, a filled rectangle. And that also takes a rectangle. Okay. And there's a bunch of options here. Center size. Let's just do, well, we don't need that. I guess we already have this rect from the actual area. So that makes a lot more sense. So let's draw this thing. So egui shape rect filled, and we use the response rectangle. Then we need a rounding, which I don't know what is. Can I just do 0? And then we need a color. So let's do color 32 from, we also have RGBA stuff. But we don't necessarily want that right now. So let's add just a kind of blue-ish background. Or maybe even better, that's fine. Let's try that. Let's see how it looks. All right, so that shows the area we can paint in. But now we want to actually draw a curve. Okay, we can do something that I found from the demo, from one of the demos, that lets us work with coordinates that go from 0 to 1. That might be a little bit nicer. Just a little bit more convenient to work with. So what you do is you set up this kind of transformation that goes from 0 to 1 to whatever the rectangle is. And E capital. And what we can do is now we can say, okay, actually I just meant 50. 50, that's kind of, or rather, let's say 0.5. I think this should work, 0.5. And then we can say to screen, multiply that, apply this transformation to this, and it should give us the same image. Yeah, exactly. Now we can work in these like relative coordinates, and in the very end, we do the transformation. So that can be a little bit nicer to work with. So we want to draw a histogram, and that's basically, you get a list of values. So let's add some values like 5, 5, 5, 7, 8, 10, 8, 7, 5. It's going to be kind of like a bell curve thing. And we want to find some kind of scale. So let's say max value is values dot. I'm not sure we can. Does that even make sense? And these can be, we can say it's hue size or something. And this doesn't seem like it should make sense. Yeah, this is just comparing to something else, which doesn't really make sense. So let's iterate and then max. Okay, so now we have the max value. And for some reason, So now we have the max value. And the minimum value, we can just let that be 0. I think that makes the most sense. And now we want to scale the values. So let's do values, iter, and map. And then we have to remember that this is a usize. So let's call it C though for count. And this should be a pointer, or a reference, so we can say copy that, turn it into a float, divide by max value as a float, minus the minimum value as a float, and we probably also want to subtract the minimum value as a float. Okay, then we can collect that, and it should be collected into a vector. So now we have values going from 0 to 1 in a custom scale, custom range, and just to show that we can even like add a little bit, maybe let's say max value equals max value plus max value minus minimum value, so the range, but maybe it's a fifth of the range we add, so we add a little bit extra. Okay, then we actually also want to know so we want to draw this as rectangles, but what are the widths of these? Now we have the heights, but what are the widths? Okay, so how many bins do we have? That's just the length of values. And what is then the bin size? Well, that's just going to be 1 divided by number of bins as a float. So I think that should be correct. Now let's add some rectangles, and we can just map over we have to iterate, and then we can map over the scaled values. Let's call it V. And we want to add some kind of shape, so let's get a filled rectangle. And again, that takes another rectangle, and that should be from something. From XY ranges. That could actually be quite nice, this one. So I think we also need to enumerate so we can keep track of which one we're at. And then here we can say, okay, the rectangle is supposed to go from ix times the bin size to ix plus 1 times the bin size. So that's the x. And the y is supposed to go from minimum value to, maybe I don't need these extra parentheses, the minimum value to the actual value. So I think that's our rectangle. Let's, for now, for fun, let's try to add some rounding. And what should the color be? The color can be, for now, let's make it red. So we map that, and we can maybe just keep it like that. We don't need to collect it, I think. Let's add the background color still. We can get rid of that, and we can say painter, extend. So this one did not work. What's the complaint? So cannot multiply. Okay. So as F32 and SF32. also did not work, probably because this one has to be F32 as well. And that also didn't work because why? Because the V is actually a reference, so we have to copy that. And that still didn't work. And what is the actual problem? So if I do this, okay, what if we put that out here and the value can be like scale values 0 and so that does give us a range, so it's not that. Okay, give me a second to handle this off camera. Okay, maybe it's just that we need it to be an inclusive range. Yeah, that some reason egui really wants inclusive ranges. So anyway, we constructed a bunch of rectangles and now we draw the background and then we add them on top. Okay, let's try that. And we don't see anything. Okay, the reason we don't see anything is because we forgot to change the coordinates. And I wonder if we can do another map and we can have like shape, and what does the shape have? It's transform. Okay, so then we can actually transform it to the screen. And this is an in place. So I think we have to, it's a, usably, can we do that? No. How do we do that? So is it just into iter? Okay, anyway, let's map it again. So we have the shape and we can say, make a little bit of closure here. We copy the shape and then we say shape transform to screen. This is very annoying. Isn't there something else we can do? Okay, this is just a shape. So can I instead just say that this is mutable and then okay, give me a second. So transform. Do we have transform in place? I don't. Not in place. I mean, we don't. So we gotta do something like this, and it doesn't actually take this, which is a rect transform. Can we just convert this? We can't. That is disappointing. How about translate? That's also not gonna work anyway. Okay, so they want a rect transform. Let's try. Actually, let's try this again. So we want to do this. This would be very nice, but it wants this TS transform. That is. we have a rect transform from emath. So emath ts transform from scaling from something, and we of course we cannot say from this, or can we? Can't. We can't do that. What do we have in this guy? Do we have the scale, have some from to, we have transform rect. Okay, let's make it a little bit simpler. So we get the rectangle here. Let's just say that we can we just multiply it? We cannot, but we can say transform rect. And I accidentally delete something. Okay, doesn't look very nice, but we have it. All right. Okay, so great. So here we have actually the histogram. Already we see an issue. It's kind of like upside down, and that is because we actually want to say 1 minus this, and then we should also, no, maybe this is correct. No, maybe, does this one have to be inverted as well? So if the minimum value is no, wait a second. So what do we need to do? We need to say actually if value is 1, then we want to start drawing from okay, first we give the top, and that is actually 1. That's actually this, and then we go to the bottom, which is always that. So this should work, and again we need this equal sign. Okay, that didn't work because is it really this? Subset 2. Well, almost. Now we just need to, yeah, because it's not from, because the, okay, so it should be like this, and we always draw to 1, because that's the bottom of the image. Okay, that was difficult. Okay, now we have the histogram, something that looks like a histogram. It's very rounded. So let's get rid of the rounding now, and let's try to, just for fun, let's try to make it, I don't know what pre-multiplication is. Let's try without. Let's try to make it a little bit transparent, and this is again Q8s. So let's make it this much transparent. Okay, and that's great. Now we want to change this. We want to change it so that what we're actually showing is the histogram of values for the image. So we have to check if we even have an image. And then we can do all this stuff. Okay, and if we have an image, we want to say, can we, okay, so what I want to do is kind of enumerate all the pixels, but we cannot really do that on a dynamic image. So we do have to convert it. This is kind of an annoying issue. We always have to convert it back and forth. So we should probably refactor this at some point to not use a dynamic image. But for now, let's just keep like an RGB option. So that should be a image, color image. And we can even, maybe we can just use this. Let's try to use that instead. So we check color image, and what do we have there? We have the pixels. And what does that do? So pixels row by row from top to bottom. Okay. And that was just supposed to be a field. Okay, so let's map those. So here we have a color. And what are we going to do with the color? Oh, so iterated. And we can pull out the bytes like this. And we want to use the color conversion function that we made. So let's get the green and the blue. So we convert it. And what we want is actually the value, which is the third one. And what's the problem here? And it's expecting floats. So that's a good point. Let's do this. Okay. So finally, let's collect it. And I think we might have to say that it's a vector. Okay, so those are the values. Now we need to count them actually. So we have to convert this into counts. Okay. So what are the bins we want? We want, let's say, let's bring this thing up here. And then the bin range, let's say the bin range is just 0 to 1. That makes a lot of sense. And then we want to count each bin. So let's say bin values. It's gonna be for each bin. Let's iterate it and enumerate it. Maybe you cannot do that, and then we map it. So, well, okay, you don't really need to enumerate, it's already kind of enumerated. So we have a bin index, and then we need to do some stuff. Let me just write a closure here. So bin start is supposed to be the bin index times, well, let's say the bin size is going to be 1 because the bins go from, the range goes from 0 to 1. So we're going to divide by this guy, and then it will be the bin size, and the bin end is going to be +1 bin size. And it doesn't like that, so we'd have to convert it. Okay. And it also doesn't like that over here. So that was not the problem, this is the problem. This is okay. So now for this bin, we have to go over all the values and count how many are inside this bin. So let's say bin count is going to be the values, and I think we can filter the value on the value being greater than the bin start and the value being less than the bin end. And then I think there's a function called count, and that's not true, and we have to iterate first. And this is a double reference. Can I just copy it like that? Now we have the count, and then actually I just want to return that, so we can do it like this. Let's collect it and put it into a vector. So arguably doing this like in every frame is probably not something we want to do, but I think we will deal with that later. Now here, instead of using the values, we actually want to use the bin values. And this is a float. Let's just, it's not supposed to be a float, it's supposed to be bin values. Okay. Let's try that. It's not doing anything now because there's no image, so let's try to load an image. And for some reason that is taking a long time. Okay, so that just doesn't work. I wonder why the pixels, there's a lot of pixels, I suppose. But even just running it once didn't seem to work. Let's do something. Let's try to save the histogram rectangles. So it's going to be an option of a vector of shapes. And down here in the canvas function, we are going to say if let some shapes equal self dot histogram rects, and probably want to just do it by reference, then we don't do all of this calculation here. We just sorry, let's go ahead and change this to rects. And these guys expected shape, found shape. So what if we clone it? So unfortunately we have to clone it because this one wants to own them. That's not so nice. But that is what it is. Sure, we can do else if. And here we don't necessarily want to do this stuff. We just want to do the calculation itself. Well, so as it turns out, we do really need to allocate something so we can transform it. Okay, it is what it is. Let's get rid of that. And then what we're going to say is self.histogram regs replace with the regs. And it doesn't like that because we have to collect it. All right. And just to have some idea of what's going on, let's like do this static histogram calculation. And collected values. Bin the values. And finally, constructed rectangles. Let's try to load. Yes. Started the histogram calculation, collected the values. So it's actually the binning that's taking so long. I think I know why. Because we did it in kind of a naive way. So let's do bin values, and it's going to be a vector of zeros. Then we want to for something pixel. Oh, let's see. No, it's not like that. So let's say for whatever value we have in the values, and then we can calculate the bin index in kind of a faster way. So let's actually get this stuff out here. Yeah, we don't really need those actually. So what should we do? We should say value divided by bin size. And then we need to round that down, floor, and that produces an F32, and then we convert to U size. And this, just for to be absolutely sure nothing's going wrong, let's clamp it to go from 0 to 1. And then we can say bin values of this bin index, just add 1. So here we were looping over the bins many times. Now we're just, over the values many times. Now we're just doing it once. And I think that should work. This one has to be mutable. Let's see. Will it be fast enough? And it panicked. So we are out of bounds. And is that because the bin size actually is +1? It's typical of by1. And again panics. Oh, it's -1. One of them is bound. Okay, so now I did it quite fast. It's supposed to have constructed the regs, but they don't really appear. They don't really appear. And why is that? So I want to do this. And we can even. Okay. Let's try again. Just one. This is weird. Let's try something. Average bin value. So we take the bin values, we iterate, we sum, we divide by the length of the bin value. And this is 32. So just sum into that. And then as F32 and here as F32. Average bin value equals to 1. That is strange. So what's the average value, like average lightness value? So that's just the values, iterate sum. These are supposed to be floats. So values, length, that's F32. It's 0.04. That's probably correct. The bin size. The number of bins is like way too large. Okay, that's another issue. Maybe the other implementation would have worked. Let's set the number of bins to 10. Let's set it to 10. All right, that's much better, much better. So now we actually have a histogram supposedly of the lightness values. And now it could actually be cool if we could sense the click. So we have the response. And we can say clicked. So if response is clicked, can we get, does this return something? No, it's just a Boolean. Can we find out where it's clicked? Clicked by. Not interesting. Like, do we have any kind of position? If it is a good idea to show where is pointer. Okay, don't know if it's that. So we have bunch of events. What there's an output event? Who knows? Click elsewhere. Interact pointer position. Where the pointer were when this. Okay. Okay. So actually this is perfect. So we can say if let sum position equals this. And then let's right now just try to print this. so we can see what kind of coordinates we are dealing with here. Okay, so it seems to be the screen coordinates. Let's try to map it from the screen to the like 0 to 1 coordinates. So I think we can just invert this, and then let's try screen. And let's say normalized position. Load, say normalized position. Now it's very close to 0 up there. It should be very close to 1 down here. And we actually just want the x value right now. So what we can say is, let's set self dot, what did I call it? Self dot value floor. Self dot value floor equal to position dot x. So now I should be able to change, and it didn't work. Nothing is happening. The reason is we're changing the value floor, but we also have to actually run that. And it's because I chose the wrong value. Let's say we actually need the normalized position, not the, actually need to do this normalized position. All right. So now if I click here, and then we click test, it changes. So you can also see this one is being set. So we can control that, and eventually we probably want to automatically detect that it's being changed, so we don't have to click. But for now it's quite nice. Also, we might want to draw a line or something like that. But this video is already quite long, so I think we're gonna leave it here, and I will see you in the next one. Bye bye.